The road runs straight east out of Strasbourg, past the silo with the rust streak and the white fence someone painted last spring. The third farmhouse on the left has a single window lit at 4:15 in the morning. You can smell the coal stove before you see the door. Inside that kitchen, on a top shelf above the salt jar, sits a paper sack of white powder. That powder costs about $3 a pound. The same powder has been on a top shelf in some Amish kitchen in Lancaster County, in some form, for more than 200 years. There is no ant trail across that kitchen floor. There has not been one in living memory. This is not folklore, and it is not nostalgia. It is one of the most quietly effective pieces of household engineering currently in continuous use on the American continent, and almost no one outside the Old Order communities of Pennsylvania, Ohio, Indiana, and Michigan knows what is in the sack. Over the next 13 minutes you will. You will know what each ingredient does at the cellular level, which laboratory finally measured why it works, the structural reason your local hardware store sells you something far more expensive and many times more toxic instead, and exactly how to apply the mixture along a single threshold in your own kitchen tonight for less than $10 in less than 10 minutes. What follows is not a tutorial. It is a small act of restoration. Part 1. The cabinet that did not change. To understand what is in the sack, the first person to read is not a chemist. It is a sociologist named Donald B. Kraybill, who has spent more than 40 years sitting at Amish kitchen tables, taking notes. Kraybill is a senior fellow at the Young Center for Anabaptist and Pietist Studies at Elizabethtown College in Pennsylvania, and the author of more than a dozen books on the Amish, among them, The Riddle of Amish Culture. The Amish, published by Johns Hopkins University Press in 2013, and What the Amish Teach Us. He is, by general consensus, the foremost academic chronicler of plain life in North America. When other researchers want to understand why the Amish keep what the rest of us cannot help losing, they read Kraybill first. His central argument, articulated across 4 decades of fieldwork, is structural rather than romantic. The Amish do not refuse modern conveniences out of nostalgia. They refuse what they refuse because they have decided, household by household, that the social and economic costs of a given technology outweigh its benefits. They keep what works without dependency. They drop what creates dependency without working. A telephone in the kitchen invites the family schedule to be set by people outside the household. So, the telephone is moved to a shanty at the end of the driveway, where it can be used but cannot dictate. A private car ties a family to gasoline prices and to a road that runs past the church on Sunday morning. So the car is left to non-Amish drivers who can be hired by the trip. The decision is not theological. It is structural. Each technology evaluated on what it would do to the household. The verdict final. The white powder on the top shelf above the salt is the same logic, applied to insects. It works. It does not require a delivery truck from a chemical company every 6 weeks. It does not breed resistance over a decade and demand a replacement. It does not put a label on the kitchen counter a child cannot read. So it stays on the shelf. The cabinet does not change because the household does not need it to. Part 2. 4 powders, 22 tables, 2,000 years. For most of the last 2 centuries, the contents of that cabinet were known to outside physicians only because the patients would occasionally mention them on the way out the door. Then, in 2025, the cabinet was finally written down. 2 physicians, Dr. Joshua Kopp, a psychiatry resident at Walter Reed National Military Medical Center, and Dr. Lisa Fritz, his research advisor at A.T. Still University's College of Osteopathic Medicine, published the first peer-reviewed survey of folk remedies used inside Lancaster County's Amish community. The paper appeared in the Journal of Lancaster General Hospital. Between February 2022 and July 2024, their team sat at 22 Amish kitchen tables. The families were not asked their names. They were given numbers, and they were asked one question: what do you actually use in this house? For the things this house faces, the answers, written down at last, formed a small, precise inventory. 16 of the 22 interviewees named yarrow root as a daily staple. Most kept black walnut tincture for joint pain. Several grew wormwood in the kitchen garden, specifically for its insect repellent properties, listing it among the most frequently cited pest plants in the entire survey. None of the families was selling anything. None of them had a brand. None of them had an incentive to overstate. The Kopp and Fritz paper is, in effect, the inventory of the cabinet Kraybill has spent his career describing from the outside. Written down from the inside, at last, by people asked the right question. For pests at the doorway, 4 ingredients appear over and over across those interviews and across the broader Pennsylvania Dutch tradition. The first is food-grade diatomaceous earth, a fine, pale powder scraped from old freshwater lake beds and sold in feed stores for a few dollars a pound. The second is boric acid, a white crystalline powder mined from dry lake deposits in the Mojave of California and the boron beds of western Turkey, and in continuous American household use since the 1880s. The third is crushed dried bay leaves, set in pantry corners and along baseboards. The fourth, for the stubborn ant trails of high summer, is a strong-smelling oil pressed from wormwood, Artemisia absinthium, the same plant whose essential oil flavored 19th century absinthe. Households that do not grow their own wormwood substitute clove oil, concentrated eugenol, pressed from the flower buds of Syzygium aromaticum. And here's the part of the story that should give modern industry pause. None of this is a Pennsylvania Dutch invention. 2,000 years ago, Pliny the Elder, Roman naturalist, admiral, and author of the 37-volume Naturalis Historia, devoted a long passage of Book 18 to grain storage. Among the standard defenses he listed for the Roman granary were dust and ash, alongside salt, oil lees, and pitch. He was copying down what every farm steward in the empire already did. The cabinet that Kopp and Fritz finally wrote down in 2025 is one Pliny would have recognized at a glance. What the Amish have preserved, in other words, is not a quaint American eccentricity. It is the European farmhouse, intact, after the rest of Europe paved over it. Part 3. The 30% Threshold. The cabinet was understood by tradition long before it was understood by science. Tradition is enough for the household that already has the powder on the shelf. For everyone else, the science is worth knowing, because the science explains why no commercial spray, however expensive, will ever do what the dust does. In 1971, an entomologist named Walter Ebeling, working at the University of California in Los Angeles, set out to explain in scientific language what the Amish kitchen had been doing without explanation for 200 years. Ebeling weighed cockroaches on an analytical balance 1 milligram at a time. He photographed their cuticles at 400 magnifications and tracked the slow contraction of their abdomens hour by hour as the water left them. After more than a decade of patient measurement, he published one clean sentence the chemical industry has never quite known what to do with. Insects, he wrote, die when they have lost roughly 30% of their body water. That figure is not a guess. It is a measurable, repeatable physiological collapse, and almost any insect that walks across a fine, dry, abrasive mineral dust will cross that threshold long before it can find food, water, or a way home. An insect's exoskeleton is sealed by a thin film of triglycerides and long-chain alkanes, its cuticular wax, whose entire purpose is to keep the insect's internal water on the inside. Diatomaceous earth, made of the microscopic silica shells of fossil algae that lived in ancient lakes 20 to 50 million years ago, is intensely absorbent. When an ant or a cockroach walks across the dust, the wax is blotted off the cuticle the way water is blotted off a counter by a paper towel. The seal breaks. Water leaves the body at multiples of the normal rate. The threshold is crossed. The insect stops moving. Now compare that to what a synthetic spray actually does. Pyrethroids, organophosphates, neonicotinoids, they bind to receptor sites in the insect's nervous system. They are molecules. Over time, surviving members of a sprayed population breed offspring whose receptors no longer accept the binding. That is resistance. It is the reason a German cockroach colony in a city apartment can become functionally immune to a major class of sprays within a single decade. A microscopic shard of silica is not a molecule. It has no receptor. An insect cannot evolve resistance to a piece of broken glass, any more than a person can evolve resistance to a paper cut. Insects have been crawling across this planet for 400 million years, longer than there have been flowers, longer than there have been birds, longer than there have been trees that bear seeds. They have never solved diatomaceous earth. Boric acid. The second powder in the threshold mixture works on a different and complementary principle. When an insect walks through a fine boric acid dust, the particles cling electrostatically to its legs and antennae. Insects groom obsessively, and as the roach or ant cleans itself, the boric acid enters the digestive tract. A 2005 study by Habes and colleagues in pesticide biochemistry and physiology documented what happens next. The boric acid vacuolizes and destroys the epithelial cells lining the cockroach midgut, collapsing the insect's ability to absorb nutrients. The cockroach starves slowly, in the middle of food. A 2020 paper from China extended the picture. The midgut damage triggers a runaway proliferation of the insect's own gut bacteria, which translocate into the bloodstream and finish the work. The kill takes between 24 hours and several days, and that delay is the point. It is enough time for the poisoned forager to return to the nest and be groomed by its sisters. The colony eats itself. 2 ingredients, 2 mechanisms, both ancient, both confirmed by 20th and 21st century laboratory measurement, both still on the shelf above the salt. Part 4. The cost of an unpatented truth. A fair question now arises. If this works, and the laboratory evidence is unambiguous that it does, why has it never been on the front shelf of a hardware store? Why has the average American homeowner never heard of it? The answer is not a conspiracy. No one is hiding anything. The answer is the market doing exactly what an unsentimental market does. A bag of food-grade diatomaceous earth costs a few dollars per pound. A pound of boric acid powder costs less. Both come out of the ground. Neither can be patented because neither is an invention. They are minerals, and the application to insect control has been in continuous documented use in American agriculture since the 1880s. No patent means no exclusive license. No exclusive license means no company will fund the marketing campaign, the brand identity, or the shelf space negotiation. A synthetic neurotoxin, sold under a trademark name in a colored aerosol can, carries a margin and a marketing budget. A bag of crushed fossil algae does not. This is, in a different vocabulary, the same observation Kraybill has been making about Amish technology choices for 40 years. The Amish ask of every new technology, what does it actually do, and what does it actually cost the household? The market asks of every product, what is the licensable margin? The 2 questions yield different cabinets. The knowledge does not disappear. It sinks below the line of advertising visibility, into the agricultural supply catalog, into the small print pages of pest control manuals, into the Kopp and Fritz paper for the physicians who need to know. One small visible thread still runs in the syndicated newspaper column begun in 1991 by the Old Order Amish writer Elizabeth Koblentz, and continued by her daughter Lavina Eicher today. The Amish kept the knowledge because the Amish keep everything that works. The rest of the country, with no patent to keep it in the brochure rack, simply let it go. Outside the plain communities, the line of women passing the powder from mother to daughter ran for centuries without interruption. Somewhere in the middle of the 20th century, in our generation, the line went quiet. If your grandmother lived rurally, in a region with cellars and grain bins and a post-war fear of pests, she may have had her own paper sack on a top shelf and used it without explanation. The Amish are not preserving something exotic. They are preserving the household chemistry your own family forgot to write down. Part 5. What the threshold asks of you. The application is simpler than the chemistry. 2 more ingredients complete the protocol. The bay leaf in the Amish pantry is Laurus nobilis, the same Mediterranean laurel that Greek and Roman households have kept in jars for 2,000 years. Gas chromatography identifies the active compounds 1,8-cineol, eugenol, methyl-eugenol, linalool, and alpha-terpinyl acetate. A 2020 study by Mishra and colleagues in the Journal of Basic and Applied Zoology demonstrated fumigant and contact toxicity against the housefly. A Croatian study on the red flower beetle isolated eugenol as the most potent compound, producing over 87% mortality at modest doses. Crushed, dried leaves in a pantry corner release enough volatile compound, slowly, to push pantry moths, silverfish, and crawling ants toward whatever surface has been dusted with the desiccant. Clove oil and wormwood oil serve the same function for surface ant trails. Eugenol, concentrated in clove, present in wormwood, dismantles the pheromone signal that foraging ants use to navigate. A drop along the highway dissolves the trail. The colony scatters and researches. Within 2 or 3 days, the established route through the kitchen is gone. The protocol itself. A small puffer bottle dusts diatomaceous earth in a film thin enough that the wood grain still shows through. Thick piles are useless. Insects detect them and walk around. The film goes along baseboards, in the gap behind the dishwasher, under the lip of the sink, along window tracks, and across door thresholds. Boric acid goes down the same way, in a separate thin band a few inches inside the diatomaceous earth line. So any insect crossing one is likely to cross the other and groom both off. Crushed bay leaves go into pantry corners, drawer backs, and the upper shelves that hold dry food. A diluted clove oil wipe, 5 to 10 drops in half a cup of water, with a drop of dish soap as an emulsifier, runs along the baseboards, once a week for the first month, then once a month after that. The single non-negotiable rule is dryness. Diatomaceous earth absorbs water before it absorbs cuticular wax. The moment the threshold gets wet, the powder clumps, the absorbency is consumed, and the kill mechanism stops. In a mopped kitchen, in a humid bathroom, on a porch after rain, the application has to be redusted after the surface dries. 2 further warnings. Use food-grain diatomaceous earth only. Pool grade is heat calcined into respiratory toxic crystalline silica. And keep boric acid out of reach of small children and pets, since it is far less toxic than synthetic alternatives, but is not edible. What the threshold mixture will not do is also worth saying plainly. It will not kill insect eggs. Cockroach oothecae and ant brood are protected inside the queen's chambers, and a full eradication takes 2 to 3 cycles, spaced about 3 weeks apart to catch each new hatch as it emerges. It will not move on its own. If an ant trail shifts to a new entry point, the dusting has to follow, and it is slow. A homeowner expecting instant results on the timescale of an aerosol can will be disappointed on the first night. By the end of the second week, the population should be visibly collapsing. Closing. The back door, 2 weeks later. 4:15 in the morning. 2 weeks from tonight, your own kitchen. The line of ants is gone. The powder along the threshold has not moved. Donald Kraybill has spent 40 years arguing that what the Amish actually teach the rest of us is restraint, the steady discipline of asking what a tool costs the household before asking what it does for it. Walter Ebeling, in 1971, wrote one quiet sentence about 30% body water. A Roman granary keeper, 2,000 years before him, dusted his wheat without knowing the number and got the same result. Tonight, your back door. If you try this on a single threshold and come back to the comments with what happened, your species, your climate, your timeline, what failed and what worked, you will be writing the next entry in a record that has been kept by hand for a very long time.